Okay, so for this problem, I went ahead and graphed it already, but we're going to use algebra anyway in order to prove what it is. But it's always good to just see if you can just take a look at what it looks like on the coordinate plane. So first, we're going to find the distance of each side. So basically, we're going to find the distance of AB, the distance of BC, the distance of CD, and the distance of AD. So the distance of AB to start with. Remember, we're taking the square root and we're going to find the difference between our x values. So 5 minus negative 2 squared, because that's our x values. And then our y values, 6 minus 4 squared. When I simplify that, I end up getting 5 plus 2 because minus and negative changes to plus. So you end up getting 7 squared plus 6 minus 4 gives us 2 squared. 7 squared is 35 and 2 squared is 4. So we end up getting the square root of 39. Now when we're finding the distance of BC, again, same thing, we're going to start with finding the difference between our x values, so 12 minus 5 squared, plus the difference between our y values, so 4 minus 6 squared. 12 minus 5 gives us 7, so that's 7 squared. 4 minus 6 gives us negative 2, so that's negative 2 squared. Still ends up equaling 49. I don't know why I made that mistake, but let me correct that. So again, this would be 49 plus 4, which is the square root of 53. And then here you get 49, and still negative 2 squared gives us positive 4, so you still get the square root of 53. All right, now we're going to find the distance of CD. Again, we're going to start with the difference between our x values, so 5 minus 12 squared, plus the difference between our y's, so 2 minus 4 squared, and we end up with negative 7 squared plus negative 2 squared, which still gives us the square root of 49, because remember, negative times negative is a positive, plus 4, which gives us the square root of 53. Lastly, we're going to find the distance of AD. Again, first finding the difference between our x values, so 5 minus negative 2 squared plus 2 minus 4 squared. So 5 minus negative 2 changes to 5 plus 2 squared, which we know is going to be 7, and 2 minus 4 gives us negative 2 squared. So 7 squared again gives us 49, negative 2 squared gives us 4, so we end up with the square root of 53. So since all 4 of these sides are equal to each other, we know this either has to be a rhombus or a square. The only difference would be if the slopes are opposite reciprocals of each other. So let's just find the slope of segment AB and the slope of segment BC. So we can see if these form a right angle. Because remember, if it has one right angle, then it would be a square because all 4 sides are equal. So the slope of AB, we're going to take the difference between our y's, so 6 minus 4, over the difference between our x's, so 5 minus negative 2, and we end up getting 2 over 5 plus 2, which is 2 over 7. When we look at BC, when we find the slope of this one, we have 4 minus 6, the difference between our y values, and 12 minus 5. So we end up with negative 2 over positive 7. Now these are opposite signs, but they are not reciprocals of each other. So most likely this is not going to be a square. I mean, it's definitely not going to be a square. Let's see if opposite sides are parallel just to make sure. So we're going to find the slope of CD. And so we're going to find the difference between our x values, 4 minus 2. And on the bottom, our difference between our x. On top is y, bottom is x. And we end up getting 2 over 7, which is the same as AB. So we know that these sides are also parallel. So this is a parallelogram, and it is a rhombus, but it is not a square. And that would be the most specific name that you can give this shape.